Let's solve this carefully, because the key to this problem is recognizing the right triangle hidden inside the quarter circle. We have a quarter circle with a rectangle inside it, and the upper right corner of the rectangle lies exactly on the curved arc of the quarter circle. We are told that the vertical distance from the top of the quarter circle down to the top of the rectangle is 4 units, and the horizontal distance from the right side of the rectangle to the end point of the quarter circle is 2 units. Our job is not to find the dimensions of the rectangle directly. Instead, we need to find the area of the shaded quarter circle. So the first thing we need is the radius. Let's call the radius r. Now, notice that the center of this quarter circle is at the corner where the 2 straight sides of the quarter circle meet. If we connect that center to the upper right corner of the rectangle, we create a right triangle. This is the important construction, because once we have a right triangle, we can use the Pythagorean theorem. Now, let's carefully determine the 2 legs of this triangle. The entire horizontal distance from the center to the end of the quarter circle is the radius, so that entire distance is r. However, the rectangle stops 2 units before the end of the quarter circle. Therefore, the horizontal leg of our right triangle is r minus 2. Similarly, the entire vertical distance from the center to the top of the quarter circle is also r, because it is another radius, but the top of the rectangle is 4 units below the top of the quarter circle. Therefore, the vertical leg of our right triangle is r minus 4. The hypotenuse is the line connecting the center directly to the upper right corner of the rectangle, and because that corner lies on the circle, this line is also a radius, so the hypotenuse is r. Now we can apply the Pythagorean theorem. Remember, the Pythagorean theorem says that in a right triangle, the square of one leg plus the square of the other leg equals the square of the hypotenuse. So here, we get r minus 2 whole squared plus r minus 4 whole squared equals r squared. Let's write that carefully. R minus 2 whole squared plus r minus 4 whole squared equals r squared. Now we need to expand these 2 squared expressions. When we square r minus 2, we multiply r minus 2 by r minus 2. That gives r squared minus 4r plus 4. Similarly, when we square r minus 4, we get r squared minus 8r plus 16. So our equation becomes r squared minus 4r plus 4 plus r squared minus 8r plus 16 equals r squared. Now let's combine the like terms. We have one r squared plus another r squared, giving us 2r squared. Then we have negative 4r minus 8r, which gives negative 12r. And finally, 4 plus 16 gives 20. Now subtract r squared from both sides. This leaves us with r squared minus 12, r plus 20 equals 0. And now we have a quadratic equation in r. Before we move forward, notice something important. We are solving for the radius. And once we know the radius, the area of the quarter circle will be very easy to calculate. So let's factor this quadratic. We need 2 numbers whose product is 20 and whose sum is negative 12. Those numbers are negative 10 and negative 2. Therefore, r squared minus 12r plus 20 factors as r minus 10 multiplied by r minus 2 equals 0. Now we use the zero product property. If the product of 2 factors is 0, then at least one of those factors must be 0. So, either r minus 10 equals 0 or r minus 2 equals 0. From the first equation, r equals 10. From the second equation, r equals 2. So mathematically, we have two possible values, r equals 10 or r equals 2. But we cannot simply accept both answers. We needed to check which one actually makes sense in the geometry. Remember, the radius has to extend far enough to accommodate the 2-unit horizontal gap and the 4-unit vertical gap. In particular, because the vertical leg is r minus 4, the radius must be greater than 4. If r were 2, then r minus 4 would be negative 2, which cannot represent the required positive length of a side of this triangle. So r equals 2 is not physically possible for this diagram. Therefore, the only valid radius is r equals 10 units. And this is the key result we needed. If you are following along, this is a good point to pause and make sure the logic is clear. The geometry gave us a quadratic equation. The quadratic gave us two algebraic solutions, and the diagram helped us reject the impossible one. Now, we can finally calculate the area of the shaded quarter circle. The area of a complete circle is pi multiplied by the radius squared. Since this is a quarter circle, its area is 1/4 of the area of the complete circle. So the formula is area equals 1/4 multiplied by pi multiplied by r squared. We already know that r equals 10, so now we substitute 10 for r. That gives us area equals 1/4 multiplied by pi multiplied by 10 squared. 10 squared is 100, so this becomes area equals 1/4 multiplied by pi multiplied by 100. 100 divided by 4 is 25, so the area becomes 25 pi square units. Therefore, the shaded quarter circle has an area of 25 pi square units. And notice how we never needed to find the width or height of the rectangle separately.